Welcome to lesson 3. Let's talk about the concept of fat balance, and let's look at a little bit of research on fat cell dynamics. So the concept of net fat balance is important because net fat balance is really the state what determines our state of body fat mass. So net fat balance chronically over time, that is what will determine whether our body fat mass is increasing or decreasing or staying the same. So net fat balance is determined by fatty acid synthesis minus fatty acid oxidation. So the net result of that is what is going on with our fat mass in terms of its size gain or size decrease. So what we have illustrated on the right is an example of body fat increase. And as you can see, with that red arrow representing fatty acid synthesis, that is overpowering fatty acid oxidation. So the lay terminology for fatty acid oxidation is you often hear it as fat burning. So when the term fat burning is said, it's really referring to fatty acid oxidation. Now, here's an example of body fat decrease where fatty acid synthesis is being outweighed by fatty acid oxidation. And at this point, I want to make a subtle but important distinction between fatty acid oxidation versus fat breakdown and the release of fatty acids into circulation. So the latter is a process called lipolysis. So fatty acid breakdown is a precursor event to fatty acid oxidation. Just because fat breakdown is happening and fatty acids are released into circulation, this does not necessarily mean that an increase in fatty acid oxidation is going to happen. So it's really the fat burning or the fat oxidation that determines fat disappearing from the body or fat leaving the body. Okay, so the final example over here is equal fatty acid synthesis and fatty acid oxidation, amounting to a net stasis in body fat mass. And so the moral of the story with net fat balance is that if fatty acid synthesis outweighs oxidation, you're going to gain body fat. If oxidation outweighs synthesis, you're going to lose body fat. If they are the same, then your body fat mass will stay the same. And so the reason it's important to, I guess, anchor on to this basic concept is because when we discuss things like fatty acid oxidation during exercise, that's fine and dandy if somebody pulls all the stops that they possibly can to maximize fat oxidation during exercise. But what ultimately matters regarding their amount of body fat they carry is, will fatty acid oxidation outpace fatty acid synthesis by the end of the day? So who really cares what's going on by the end of the 30 to 60 to 90-minute long workout? What really counts is, what is 24-hour fat balance, net fat balance? What is the net fat balance by the end of the week? And how many weeks can you string together? I have an old quote that says, caring about fat burning during exercise makes as little sense as caring about muscle building during exercise. So that little snapshot in time is irrelevant compared to the big picture. All right, let's look at the question of, is it possible to grow new fat cells as you gain body fat, or do existing fat cells just get larger? Well, in this study, they found out, well, they overfed normal weight men for 8 weeks. And this resulted in 1.6 kilograms of weight gain. And it also resulted in 2.6 billion new fat cells at the leg, while fat cell growth occurred in the abdomen. So the two different terms, hyperplasia means an increase in the number of cells. Hypertrophy means an increase in the size of the cells. So hyperplasia occurred in fat cells in the lower body, whereas hypertrophy or the growth of the cells occurred in the upper body or the abdomen. Pretty interesting result there. So this study was looking at a similar phenomenon, but it was 8 weeks of overfeeding followed by 8 weeks of underfeeding. And during the overfeeding phase, the subjects gained 5% of their body weight at baseline. In other words, they gained 3.1 kilograms. And in the hypocaloric phase, they lost 80% of that weight. And what happened was gains in abdominal, subcutaneous fat, and visceral fat were completely reversed after the 8 weeks of underfeeding, but lower body fat did not completely return to baseline levels. So there appears to be a higher degree of stubbornness about the adipose mass in the lower body compared to the upper body. And abdominal and femoral adipocyte sizes, but not numbers, decreased with weight loss. So it was concluded that lower body fat loss is due to reduced fat cell size, but not reduced fat cell number. So there it is. These past couple studies seem a little bit trivial, but in case somebody asks you the question of, do fat cells increase in number or do they increase in size? Well, what's the answer to that question? You can say, well, it's a little bit nuanced. And then you can relay the results of these studies if you ever find yourself in that situation. And with that, we conclude lesson 3. I'll see you back in lesson 4, where we'll take a look at the carbohydrate insulin model of obesity.